Hello, my name is Sophia Hohenstatt. I work in the Department of Neurology at the University Hospital in Heidelberg in Germany. I encountered microplastic as a mix of personal coincidence and scientific interest. As a background, I kind of grew up in a household where plastic was not very welcome. We used to put everything in glass jars, and before it became a trend. And then when having a small kid, when I sterilized the bottles of plastic, I realized how quickly they get cloudy, and so this was like my background at that time. And then my partner, radiologist, sent me over an article from radiologists, which was also about plastic. And what they did, they analyzed microplastic levels in carotid plaques and linked it to a composite endpoint of stroke, myocardial infarction, and death. And then it kind of all came together. And I thought, well, if they have stroke being associated with microplastic and we are the ones handling stroke, I don't want us to lag behind again years after cardiology. I thought it's a good time to take action and actually look at this and explore it more. We wanted to explore further this link between microplastic levels and stroke. And to do this, we decided to test for microplastic levels in blood because this is ideal for biomonitoring. So surgical tissues are not good for this purpose. But this opened also a big uncertainty because until that time point there was no data showing microplastic in blood. It was all based on microplastic in other surgical tissues. And so I was very glad that Esmond kindly endorsed this project financially because it was a high-risk project. And small disclosure, we found microplastic level, fortunately or unfortunately, in nearly every sample. So once the most basic organizational part were secured, the funding, the clinical question we wanted to answer, I started to look more at the practical part of organizing the study. And so one important thing is to have a so-called plastic-free protocol when sampling. This means that you don't want to use plastic syringes or all the equipment we normally use in clinical practice. You want to go totally plastic-free, use glass syringes, stainless steel needles, glass tubes for blood storing. And this is because we wanted to ensure there's no cross-contamination, so no uncontrolled release of plastic polymers through our sampling material. And this opened up the next research question, which is, I was wondering if it's so easy to contaminate a blood sample, and we do introduce catheters made out of plastic all the time into the vasculature. We probably might have also a release of polymers there. So the next question essentially was, is there a iatrogenic procedural contamination during neurovascular procedures, and what is the magnitude of this contamination? So in the first study, where we explored the association of microplastic blood levels with stroke, we did include 30 patients, either having acute ischemic stroke or being healthy individuals. And what we found is that there was a trend towards higher microplastic blood levels in stroke patients compared to healthy individuals. We also expanded this analysis and pooled the data with other studies that had data about microplastic levels in healthy individuals. And when pooling them, the results reached statistical significance. So higher microplastic burden in stroke patients. And I do acknowledge that there are some limitations with pooling data because it comes from different labs. But there is also some data about the inter-observer reliability of this methodology. And so basically, if the steps in preparation of the blood samples is similar or equal, then it's very reliable. The results should be comparable. And this is the case for the studies I included. I made sure that all the preparation steps were nearly the same. So I think having a larger sample size would probably solve the issue of the statistical significance. In regard to the procedural contamination, we also find that during endovascular procedures, we have polymer release in the microplastic range and also in the nanoplastic range, so even smaller particles being released. But for now, we can just acknowledge that there is this release since the biological consequences are not wholly understood. One other thing I would like to mention, and this goes beyond microplastic actually, is that we found another very concerning contaminant in released during endovascular procedures, and this being PFAS. And you probably know this substance. It's also called the forever chemicals, and you know it from non-stick frying pans. Essentially, those are known to be highly toxic. And we did find a release that was not 10 times, not 100 times, but up to 4,500 times increase above regulatory thresholds for drinking water. So I think this is really something to address and to be concerned about. So one of the limitations about our findings about the procedural contamination is that we could find this only in a controlled benchmark model where we could retrieve every particle release. So we simulated procedures in glass jars essentially, and we deliberately avoided flow models because those are made of plastic. But when we tried to replicate to find these results in vivo, so by sampling directly arterial blood from patients, and we did include 10 patients that underwent elective aneurysm treatment at 2 predefined time points, so once at the beginning of the intervention and once at the end, and looked at a possible delta between pre and post procedural values, we could not replicate the same findings. And I think there's some explanations for this. First of all, because we did sample in blood a very tiny amount of blood, 2 to 3 milliliters out of a 5-liter pool, and we still don't know how these particles behave, how they distribute within the body. And then the second consideration, and it has partially to do with the first one, is that those particles that we found in the benchmark model are most commonly in a size range between 20 and 100 micrometers, which is by far larger than capillary size. So probably what happens in vivo is that they do get trapped at the microvasculature and never reach the post-procedural sampling site. So there's obviously a lot of research that still has to be done, starting from how variable is this sampling. If you do repetitive sampling in the same patient, is there variability? How much is this variability? We need to understand if these microplastic particles get trapped at the microvasculature level, and there's evidence for this. Interestingly, the German Alzheimer Foundation put microplastic as an official risk factor on their website. And there's starting to be evidence that microplastic might also behave or cause something like small vessel disease, acting as atherosclerosis, essentially blocking small vessels in the brain. So there's a lot to explore. And one thing we can do as a community is focus on the acute stroke implications, and starting from a larger multi-center study and building up on that. What is really nice to see in our community is the genuine interest I'm getting from a lot of colleagues that would like to help in this in a multi-center effort to elucidate further this possible link with stroke patients. And this would be very nice to go multi-center and cover quite a lot of Europe in order also to see if there are regional differences, because for now most of the microplastic comes from environmental exposure, and there might be also differences if you're in a more urban setting or in a more rural setting and so on. So this is just generally very nice to see the interest of fleas. I think what we collectively can do as a community, and this goes beyond us being physicians and endovascular neurosurgeons, is that we can simply try to reduce our plastic use. I know this is very difficult. I know plastic is very handy and common, but I think there's small intuitive changes we all can do. We can try to avoid plastic bottles whenever we can, or just less packaging. It's small, I think, intuitive changes we can do for now. So I would encourage, and if I might add, maybe for industry, one idea could be to reduce packaging also for the devices, or reduce the use of like nice plastic gadgets we get at conferences, which are absolutely lovely. We all adore them, but they're probably not so good for the environment, for future generation, and apparently also for our own health. I think there are many ways how industry could also help in this common effort. The first thing, I think, as I mentioned before, would be to reduce packaging, and this is quite straightforward. It doesn't implicate any change to the devices or in their functionality. It's just simply debulking a bit the packaging, which is also good in general for our environment. What I also think would be good is have more transparency, and I do also acknowledge that sometimes industry is just not able to share all of the information, and this is somehow also fine. But maybe to have some more, informal or not fully official chat with engineers would be very, very helpful also for us clinicians, and maybe to have more collaborations on this. So this is also an open call for engineers. If they want to exchange more on this topic, they're more to welcome to come up to me. And then I think, as I said, also all those gadgets, probably we can cut on these as well.